Hello, everyone. We are in week 5 of Algebra 1A. We are going to go over point slope form. All right, so for those of you who made it this far, I'd just like to say good job. And let's jump in it. All right. So we have our vocabulary. It's going to be hopefully a shortish lesson, but we'll see. Point slope form is a line with slope m that contains point x1, y1, and can be described by the equation x minus x1 equals m parentheses x minus x1. Make sure you have that written down. Additionally, make sure you also have this other part written down, slope formula, which you will need at some point throughout this lesson. Um, Slope formula is y2 minus y1 divided by x2 minus x1. And we use the slope formula to determine the slope between 2 points or of a line. So basically, if you know 2 points of any line, you can determine its slope, whether it's given to you or not. And this is going to be important because for some of the problems this week, it's going to require that you know what the slope is, but they're not going to give you the slope, right? And that's not going to be the entire problem either. Like no one, no, like there's going to be no problems on here that's going to say just find the slope. That's not going to be a problem this week. This week is going to be find the equation and make sure that the equation is in point slope form. However, in order to do that, you're gonna need to use the point slope formula to find slope sometimes. So a real quick lesson about what that looks like. Right, we're down here right now. Uh, this is just 2 points, right? One of them we're gonna label as x1, y1. The other one we're gonna label as x2, y2. You might be wondering, does it really matter which one is x1 and each one is y, x1 and y1 and x2 and y2? The answer is no. No, it doesn't. However, depending on the numbers and on the negatives, which some of them might be easier to solve depending on how good you are with negatives. So what I mean by that is I could label the top one x1 and y1, or I could label the bottom one x1 and y1. It doesn't matter. Just pick one, label them, and then plug them into the equation. So here, right, we know that my for the equation we have y2 minus y1. Y2 in this case happens to be 3, which is where this 3 came from. And then if I look at y1, it's this one right here. Y1 happens to be 1, which is where that positive 1 came from. However, there's a minus right there. The minus is from the slope formula because if you notice right here, it's x2 minus x1. So x2 being 3 minus x1 being positive 1, we end up with 3 minus 1. If I had if the 1 had been a negative 1, I would have ended up with 2 negatives. I would have ended up with 3 minus 1, and I would have had to turn that into a positive. All right, but we'll go into that a little bit more later. For now, we don't have to worry about it. Right now, x2, right? My x2 happens to be 5. That's where this came from. And my x1 happens to be 2, which is where this came from. So I just plugging them in exactly the way I see them. Since they all happen to be positive numbers, and the only minus came from the equation, I just plugged them in. I ended up with 3 minus 1, which is 2, 5 minus 2, which is 3, and I ended up with 2/3, or 2/3 is my m, or 2/3 is my slope. At which point, now that I know what my slope is, I can put them into point slope form so I can figure out what the equation is of this line, right? More on that in a bit, but this is different from last week because last week what we were doing is we were talking about slope intercept form. This, do not get confused because slope intercept form, what that would do is this right here. This is the difference. If you knew what the y-intercept is, as in you knew where this line crossed the y-axis, then you can use y-intercept form, right? That's when you use that. However, if you don't know and we have a situation where we have a closed line like this, and it's not touching the y-axis, and you don't you don't have a y-intercept at all, you would need, that's when you would use point slope form. They're both forms are kind of used to solve similar types of problems, and a lot of people get these two formulas confused. Just know that one is not necessarily better than the other. Just know that for now, this week we are going to focus on point slope form, just like last week we focused on slope intercept form. Okay, moving on. How can we use point slope form to form an equation? Right. Okay. Problem: write an equation in point slope form for each line. The problem that we have for right here, where right here, slope is 3.5 and the coordinate point is -3, 2. Before I do anything else, I'm going to just really quickly just label these for my own sanity, because otherwise I forget. We have x1 and y1. How do I know which one to put? Well, I only have one coordinate point, so I'm only going to put x1, y1. I'm not going to label them x and y, and there's a reason why I'm not going to label them x and y. Okay, interpretation. Okay, so to find the equation for the line for the line which it describes, all we have to do is substitute the information given into the point slope form. All right, so we just start off with the equation. And as I've shown you in the vocabulary, this is the equation for point slope form, right? Y minus y1 equals m parentheses x minus x1, right? Then the next step is we need to just substitute what we know. Now they straight up tell us slope is 3.5. And if you remember, slope is represented by the variable m. So all I have to do is replace m with 3.5. Notice how there's two y's and there's two x's in this formula. X1 and y, right? X and y are different from x1 and y1. Specifically, x1 is referring to my coordinate point, the first, right? The first number in my coordinate point, and specifically y1 is referring to the second point, which happens to be 2. I'm gonna plug them in and those points. Like there is a distinction. You cannot confuse those. Do not put -3 and 2 where the y and the x are, right? Because our goal for now, right, is we're just writing an equation, remember? We're actually not solving anything. If the problem is just like, hey, can you write an equation and can you make sure it's in point slope form? All you're doing is you're trying to come up with an equation that's in this form, right? So when we substitute, we end up with y minus 2 is equal to 3.5 parentheses x minus 3. Because remember, we're plugging in a negative, right? And there was a minus from the original equation, right? Right there. So that's how we ended up with two negatives, all right? Okay, so step 2 right here, after we're done, you know, after we finish plugging everything in and we've, put in extra parentheses and all that, we just need to fix the double negative because everything's all good. We're like, remember, we're not solving anything yet. Not yet, anyways. So here, the double negatives become a positive, right? And that's it. That is my equation. Okay. Uh, that's it. So make sure you have this example written down. Over here, this is just a vocalization. This is just me typing out what I said earlier, which is why do we need uh, point slope formula when we have slope intercept form? Well, again, if you specifically know what the y-intercept is, then yeah, by all means, just use the slope intercept form. For those of you who don't remember from last week, you know, this was the equation you were using last week, and this is the equation that you're using now. So, we're focusing on this equation. This one was last week. Man, I just cannot spell. Okay, hold on. Yeah, this one was the one we were focused on last week, right? And this one's a different one, right? This one's the one that we're using now. So, oh, okay, never mind. I won't do that. Okay, so yeah, so just know that they're used in different situations. Like if you're missing one piece of information, you can use one of them. If you have a certain piece of information and you if you have just the coordinate points and just the slope, I guess you can argue you can use both, but it just depends, right? Because the difference is this. What is going on? Okay. Okay. Sorry, technical difficulties. Okay. So yeah, so pretty much just you have to read the problem, right? If we were doing this in a normal class, you would see a mix of problems. Like you would have to distinguish which one is which one, right? For now, we're just doing each week. We're focusing on a different one. So just keep that in mind. But we're gonna move on to the next one. Word problems that require point slope. Uh, so here you're gonna have some word problems to do, right? The key about the word problems and the reason why it sounds more convoluted than it has to be is because the word problem has multiple parts. So for here, right, the problem says Paul wants to place an ad in a newspaper. The newspaper charges $10 for the first 2 lines of the text and $3 for an additional line of text. Paul's ad is 8 inches, 8 lines long. How much will the ad cost? Right? Okay, so our interpretation, we need to assign values to what we're trying to do here. So our interpretation is let X represent the number of lines of the text, let Y represent the cost in dollars of the ad. Now, I want to just, before we move on, I want to real quickly look back to this. Do you guys remember when I said that it was really important that you put these in the correct spot, the X1, Y1, right? Well, this is the reason why, because our coordinate points mean something. And the actual variables mean something else in the context of a problem. Now, this may not be as obvious the first time you look at the equation when you're just looking at numbers, but when you're looking at a word problem like this, it becomes pretty obvious what means what. So in this case, right, Paul has a problem. He wants to place an ad in the newspaper, but he wants to know how much it's going to cost him, right? The newspaper has their rates already set up. They're saying that they charge $10 for the first 2 lines. Okay, cool. For the first 2 lines of text, and $3 for the additional line. And he wants 8 lines. It should be relatively easy to just count because the numbers are really small, and I shouldn't even have to use this formula. But the truth is, in the real world, there are problems that are much more complicated than this, and it's much easier to use this formula when the numbers get more complicated, right? So for the sake of argument, we're going to let X represent the number of lines of the text, right? How many lines he wants. And if you just saw, he wants to have at least 8 lines of text, right? So X represents, lines of text. Okay, we're going to keep that in mind, right? We're also going to let Y represent the total cost in dollars of the ad, right? So Y represents cost, the number of lines, right? So each one represents something else. This is just what Paul wants, right? And how much it's going to cost him. That's his bottom line. Now, how are we going to actually get those costs? Well, because 2 lines of text cost $10, the point 210 is on the line. What we're doing here, what we're really trying to do with this is, yes, I could come up with the answer pretty fast if I just added, but really what's going on here is I want to create a graph. I want to create a line so I can predict cost not only for what happens if Paul's ad is 8 lines long, but what if he changes his mind? And what if he's like, well, how much is 10 lines going to cost? How much is 20 lines going to cost? How much is 1,000,000 lines going to cost? Right? Then all of a sudden, when the numbers get outrageous, counting isn't really the best option, right? However, if you come up with an equation, it doesn't matter what number of lines, it becomes really easy to calculate the final cost. As a matter of fact, if you're a business and you go up and someone comes up to you and says, I want this amount of lines, how much is it going to cost? All you would have to do is put in the lines that it costs and you can essentially figure out the cost. That's pretty much what a register at a cashier does for you. You put in how much how much of something, how much it costs, and it does the math for you. Well, this is how it does the math. Okay, so let's set this up, right? The point 210. We know that because 2 lines of text is going to cost 10, that's going to be, if we were to graph this, right? 210 would be somewhere right here, right? Let's just pretend on a line. And the rate of change costs $3 per line, right? And we're trying to figure out what that is, right? We're trying to figure out what the next line would be, or the line below it, or all the dots on this imaginary line, right? That's really what we're trying to do here. Okay, so how do we do that? All right, part one, create your equation using point slope form, right? Y minus y1 is equal to m parentheses x minus x1. Point slope formula. Cool. We always start with our formula. All right. Now we need to create our equation. That's the first part, right? So all we need to do is put in the information that we know, right? We have our slope, and we know that because they're charging $3 for every additional line, our slope is going to be 3, right? Because that's the key here is change. Whenever you see rate of change or something of change, chances are they're probably talking about slope, right? That's the key word. And as far as what x1 is and y1, well, remember, these are indicative of your coordinate point, right? Of your point of reference, where you're starting, right? Their base of where they're starting is essentially 2 and 10, right? That's the coordinate point they give us. This is x1 and this is y1. Okay, so now that we have all of our information, we're going to plug it in. We're going to substitute x1 and y1 from the coordinate point and the slope into the equation. Cool, we did that. We have our equation. We're done, right? Because that's what we did in the last slide. Well, we're done with part one because really they're asking how much will the ad cost, and so far I just have an equation, right? So I haven't really answered the question. Moving on to part two. Use this new equation to answer your problem by substituting the line of text, how much you want. Remember we said that the line of text was your x value, and we know that our x value is going to be 8. So we're going to plug that in, and we're going to use that to solve for y. Y is ultimately going to be our cost in dollars, and that's what we want to know. So y is going to be on one side of the equation. It's going to be by itself, and we're going to be isolating for y. All right, so we're going to start with the equation we had from earlier. I just simply rewrote it down there. That's step one, use your equation from part one. Next, step two, substitute the lines, number of lines Paul wants. He wants 8, so we're going to substitute 8 for x, right? So that's what we did there, right? Now that we have actual numbers there, we can actually solve this now. Now what we're going to do is we're going to solve the inside of the parentheses first, right? 8 minus 2 is just 6, which is how we got this 6 down here. And then we have the 6 in the parentheses. The parentheses didn't go away yet. We're going to move on to the next step, which is we're going to multiply against the number on the outside, right? So 3 times 6 is going to be just 18, right? So we have y minus 10 is equal to 18. At this point, we're going to want to isolate the y. And we're going to do that by inverse operations, right? So we want to get rid of the 10. And since we have a minus 10, we're going to do the opposite of minus, which is plus, right? So we're going to add 10 to both sides. 18 plus 10 is 28. Y is equal to 28. And remember, y represents cost, which means the cost of Paul's ad that has 8 lines will cost $28, right? Okay, cool. But like I said, what about my example? What if I wanted something ridiculous like a million lines or something? Well, really, I could figure it out. All I need to do is instead of putting in 8s for x, I could put a million in there, and then I can figure out how much it'll cost. Or I could put 648,000, or I could put 0, right? Um, and like if I wanted to run the crazy thing is, according to this formula, if I wanted to run an ad with 0 lines, but I still wanted to run an ad for no reason, they would basically charge me $10, right? Because look at my equation. y minus 10 equals, or would it, right? Let's say I wanted to run 0, right? 0 minus 2 is just, right? We're going to do this, y minus 10 minus 6. Actually, no, I was wrong. Whoops. How much would they charge me if I ran absolutely no lines, but I still wanted to run an ad with my name for some reason, right? The company would charge me $60 to run an ad with no lines, an ad that said nothing. I mean, I don't know why anybody would do that, but there you go, right? Yeah, I can use this formula again and again and again, put any number in there and figure out this is what a cash register or a machine or a calculator does all day, every day, right? But the calculator couldn't figure out the equation. You, as the person, needed to put the equation into the machine so that the machine could then solve the actual problem, right? So the smart one is you. All right, moving on. Write a point slope form using only 2 coordinate points, right? All right, so at this point, um, we're just gonna we're gonna posit the question of what happens if they give you 2 coordinate points and then they're asking you, hey, can you still write an equation and make sure that it's in point slope form? But I'm not going to give you all the information. I'm just going to give you 2 points. Could you do it? The answer is yes, and here's how. They want you to write an equation on these 2 points. Before I do anything else, I'm going to just label them x1, y1, x2, y2. If you're wondering why I'm emphasizing this so much, I've seen a lot of students get this wrong because they don't label them properly. I've seen some students label it x1, y2 for some reason. I've seen some students label them backwards. I've seen people do all kinds of different things with this. It's x1, y1 for one of them, and then for the other coordinate point, it's just going to be your x2, y2. And for those of you wondering, what if they give you 3 coordinate points? Pick 2 of them. Just pick 2 of them. Like, if a problem gives you more information than you don't need to use all the information. Sometimes you just need to use the information that you need to use, right? Um, like, if I were to give you 10 coordinate points and told you to write an equation in point slope form for 2 of these points, you really only need 2 out of the 10 coordinate points. Do you guys get what I'm saying? Okay, so it's just a small point there because a lot of people get confused with that. Okay, so back to the problem, interpretation. Okay, so before you do anything, you need to realize you cannot create an equation without slope. Luckily, you have 2 coordinate points, so you can use slope formula to find slope using point slope formula. Okay, and then all right, yeah, that was worded really awkwardly. The point is, before you do anything, if you're only given 2 coordinate points, the first thing you should always do is do this, which is use point slope formula to find the slope. Now, if you remember from the previous slides, from slide 1, in order to make slope, you need y2 minus y1 divided by x2 minus x1, which is where our labels come in handy, right? So x2 in this case happens to be what? It happens to be 4, which is why I have 4 there, right? Y1 happens to be 1. I always do all the y's first, and then I move on to the x's. That just kind of helps me organize. Do it however you want. Just make sure you're keeping track somehow. X2 is 3. And that's a terrible one. Okay, and X1 should just be 2. Okay, so 4 minus 1, just 3, and then 3 minus 2 is just 1. 3 over 1 is the same as 3 being divided by 1, which is just 3. So my slope is 3. So right away, we now know that our slope is 3. All right, cool. We did this, right? We know what our slope is. Let's move on. Now start with step 2, use point slope formula. Cool, I wrote it down. Y minus y1 equals m times x minus x1. Cool. Now step 3, substitute in one of the coordinate points. I chose the first one, right? I chose the coordinate points 2, 1, because honestly, it looked easier. I mean, it wasn't even that much. These are your two options, really. Um, Personally, I always go for the easier ones, the easier looking ones, because it's math, and even though I like doing math, it just it seems like this one is an easier number to work with. It's got a 1 in it. Anyways, so I chose to do this one, and I put it into this equation, right? And I substituted it, and that was it. Y minus 1 equals 3x minus 2, right? Remember, in this problem, they're just asking us for the equation, and that's really it. They're not asking us to graph it. They're not asking us to do anything else, anything crazy with it. If this was a word problem and they wanted to know, like, oh, hey, can you figure out how much of, if x was something, can you figure out what y is? Yeah, sure. Just plug in whatever value for x and you can figure it out. Right? Most of the word problems that you're going to be doing are going to be that. It's just the extra step is figuring out what your x value is, or what they wanted, what information they gave you and what they want to know, and then just putting it into the formula you just created. And that's it. That's all I'm looking for. Um, there's an alternative other formula down here, right? What if you decided, you know what, I don't like X1, my one, I don't like the look of that one, it looks really suspicious, whatever, you can use the other one, right? And if you use the other one, the equation is y minus 4 is equal to 3x minus 3. And that's it. Believe it or not, either or is correct. And if we had a word, if you're like, well, it doesn't, if you have different numbers, doesn't that change, your value at the end? Um, Kind of. But really, what's going to happen is if you have a word problem and you're like, hey, if x is like 3 or something, or x is 0 or something, what's going to happen, right? Truth is, you're going to end up with the same thing. You're just going to have slightly different looking steps, but you're really going to end up with the same thing. Why? Because those 2 points are on the same line. Now, if those 2 points were not on the same line, then you can't do any of this, right? This whole point slope form is predicated on the fact that these 2 points, coordinate points, are on the same line. If you have one coordinate point from one line and another coordinate point from a different line, then unless those two are making a separate third line, then you can't really do that. But the problems I'm going to give you aren't going to have. I'm going to go that deep. It's the last week, guys, and I thought we would end it like this. Good luck. Make sure you do all the work. And, for those of you who have contacted me um, about your grades and all that stuff, like, just make sure to check your emails. I pretty much gotten back to everyone at this point. Everyone should know where they're at. And that's it. Good luck, guys. See you later.